Relations and functions. First, we'll go through a few definitions. A relation is a set of pairs of input and output values. The domain of a relation is the set of inputs. Also, we call it the x-coordinates of the ordered pairs. The range of a relation is the set of outputs, which is also the y-coordinates of the ordered pairs. A function is a relation in which each element of the domain corresponds to exactly one element of the range. The vertical line test states if a vertical line passes through more than one point on the graph of a relation, then the relation is not a function. A function rule is an equation that represents an output value in terms of an input value. The independent variable x represents the input of the function. The dependent variable f of x, sometimes also called y, represents the output of the function. Now we'll do a few examples here that will show if a relation is a function or not. In this first one, we see that this one value in the domain is going to three different ranges, so that makes this not a function. Because it goes to multiple ranges. The second one, in the domain, all three of them go to a range number. It doesn't matter that they all go to the same range, but one domain does not go to multiple ranges. So this is actually a function. Because every domain has a range. And none of them repeat. Okay, and this other one, we would look at the vertical line test and see that any vertical line you put, it will only hit the graph once. So we would also say, yes, this is a function. Because it passes the vertical line test. Here's a few more examples of graphs. Okay, so this first one, if we draw vertical lines, we can see that it's going to hit the graph at multiple places everywhere. So this would be no, because it fails the vertical line test. This next one, if we do our vertical line test, we see that it only hits the graph once, so we would say yes, it is a function because it passes the vertical line test. Okay, and this next one, if we're very careful about drawing them, we see that there is one vertical line right there that is going to hit at two different points. It hits right here at this point right there and at this point right there on the same vertical line. So because of this, the answer is no, because it fails the vertical line test. So you got to be very careful when you're trying to draw your vertical lines. For these next examples, we need to identify the domain and range. So for this first example, the domain is all possible x's. So as we look left and right on the graph, we see that every x is accounted for. So to write our domain, we would go from negative infinity up to positive infinity. And that would be how we'd write it. The domain is negative infinity to positive infinity with parentheses. The range would be, you find your highest possible point, or your lowest possible point. Your lowest possible point is infinity, because the arrows indicate it going on forever. So we're going from negative infinity up to, my highest point is right here. So that would be 1, 2, 3. So we're going up to 3, and it includes the 3, so we do a square bracket like that. Next one, we're going left and right forever. However, there is one opening right here that does not have a point accounted for. It's an open circle. So my domain would go from negative infinity up to, but not including, negative 2. And then we're going to pick it back up at negative 2, but not including that negative 2. And then we're going to go up forever, because this point is actually filled in, so it counts on the graph. So we're going up to positive infinity. And then my range is the up and down. Well, it goes up and down forever, and even though this point is an open circle, it is still included on the y all the way along this line. So my range is negative infinity up to positive infinity. And the last example here is we're looking left and right. This time there's no arrows on the end, so we actually have to look at where it stops. My domain, the furthest to the smallest number we have, is right there at negative 1, 2, 3, 4. So from negative 4, and we're including that negative 4, so I do a square bracket like that, up to, and we keep going up and up and up, and then right at the very end, there's an open circle again. So that means that it's not going to be included. 1, 2, 3, 4, 5. So we put a parentheses around the 5. And then my range is my up and down. So we start with my lowest y, which is right there at negative 1, 2, 3. And that is included because it is a filled in circle right there. So a square bracket. Up to, my highest is 1, 2, 3. And once again, it's included on the graph. It's a point that's included. So that's your domain and range. For this next example, we are simply going to evaluate the function. So whenever it says something like this, you're just taking that number and putting it in for the x. So f of 0 is going to equal 8 plus 4 times 0. So 4 times 0 is 0. 0 plus 8 is 8. So f of 0 equals 8. Then we have the next one, which is f of 1/2. So we have to put in 1/2 for the x. So that would be 8 plus 4 times 1/2. Here we need to do order of operations. 4 times 1/2 is 2. So we have 8 plus 2, which is 10. So f of 1/2 is 10. And the last one is negative 2. F of negative 2 equals 8 plus 4 times negative 2. 4 times negative 2 is a negative 8, so 8 minus 8 is 0. F of negative 2 is 0. So that's how you would evaluate a function. This next example, we're literally doing the exact same thing for this function. So if we put in 5, f of 5 equals 5 squared plus 8. 5 squared is 25, plus 8 is 33. Then we're putting in negative 1. Negative 1 squared plus 8. Negative 1 times negative 1 is positive 1. 1 plus 8 is 9. And the last one, f of 4. 4 squared plus 8. So 4 squared is 16. 16 plus 8 is 24. So that's how you would fill in your table. These next two examples are really the same thing. All we're doing is plugging in our numbers or plugging in what we have. So f of 190 would be 4 times the square root of 190 minus 174, which would be 4 times the square root of 16, because 190 minus 174 is 16. Square root of 16 is 4. 4 times 4 is 16. So f of 190 is 16. And the last one, probably the most difficult one, we're going to put in x minus 1 instead for every x. So negative x minus 1, so we're taking that in and putting it in that x right there, squared minus 7, and then we're going to also put it in for this x right here, x minus 1. At this point, we need to simplify it down, which is the hard part. So here we need to actually FOIL that out. So I'm going to come over on the side and do that work. X minus 1 times x minus 1, x squared minus x plus 1. So that's minus 2x right there. So I'm going to move it back over here. X squared minus 2x plus 1 minus 7x plus 7. And then simplification, because that needs to be distributed in there. Negative x squared plus 2x minus 1 minus 7x plus 7. And then combine your like terms, the 7 and the negative 1, the 2x and the negative 7x. So f of x minus 1 is equal to negative x squared minus 5x plus 6. Make sure it is simplified all the way. All right, we have two more examples here. A carnival charges $5 entrance fee and $2 per ride. Write a function to represent the total cost after taking a certain number of rides. How much would it cost for 13 rides? Okay, so for when we're actually writing the function, the cost in terms of the number of rides is going to be equal to $2 per ride plus $5 to just enter the park. So that is your function. And then we just have to figure out, if you want to ride 13 rides, how much is it going to cost you? 2 times 13 plus 5. 2 times 13 is 26 plus 5. So the cost of 13 rides is $26. Oh, sorry, $31. 26 plus the 5. And the last example, you can estimate the temperature by counting the number of chirps the snowy tree cricket makes. The outdoor temperature is about 40 degrees Fahrenheit more than 1/4 the number of chirps the cricket makes in 1 minute. What is a function rule that represents this situation? And what is the temperature if the cricket chirps 150 times in 1 minute? So the temperature based on the cricket chirps is going to be a fourth of the number of chirps, 1/4 of the number of chirps that the cricket makes, plus 40 degrees Fahrenheit. Okay, so there's your function. And now we have to just solve that for what's the temperature if the cricket chirps 150 times. So that would be T of 150 equals 1/4 times 150 plus 40. And then you can just type that into a calculator. And when you do that, you get T of 150 equals 77.5. So that means that it would be roughly 77.5 degrees Fahrenheit when the cricket chirps 150 times. In a minute. That is it for the skill of relations and functions. You should be able to go through your notes and summarize, and let me know if you have any questions, and we will do the worksheet and the quiz soon.